If you find these videos helpful, please consider supporting AddOhms and the Bald Engineer on Patreon. Hello everybody, how are we doing today? Why does that have noise on it? Let's turn that off. Hi everyone, my name is James. Welcome to a live stream. If you can hear me, let me know in chat the name of a component and then we can get started. Yeah, Geek Boy, that was a new intro graphic and I'm working on another one. There's a channel I follow. The guy does a really nice job of putting together templates, and this next one I'm working on I really like. I think it's gonna be quite a bit better, but it's also quite a bit longer. Wire wound resistor. Oh man, that word always messes me up. Interesting. Is this showing up in the chat over here? It is. I wonder why that's happening. I know, Sebastian, you are not constantly saying pull-ups, but for some reason the chat keeps repeating it. Let's see if it stops now. I am the capacitor man. That is a... Yeah, I used to work for a capacitor company. Used to do a lot of discussions on caps. But now I work for a test measurement company, so I got away from the components. Man, we might have to turn the YouTube chat off because it looks like it's broken. Let me try something and then we're gonna get started. We're basically gonna work on KiCad tonight. Originally, I was planning on doing something different, or what I was originally planning to do is finish the 2GS schematic on Sunday. But I've got something that came in that looks really cool. I got this board, and it is a machine learning board that has a camera on it. And I think one of the applications it has is, or meant for, is doing like verification. Verification, I think. Not verification. Is identifying individual faces. And so I sort of want to like make some kind of like lockbox or something to go along with this. But this is, I think that's going to be kind of a cool thing to play with. And so I think we're going to play with that on Sunday. The reason I didn't want to do it today is, okay, let me see if I can actually disable this because it's kind of messed up and it's bugging me. Let's see, that is what I have open. Then I come into settings, but I'm actually going to be writing a long article on machine learning and artificial intelligence, and so I want to play around with that board and see what it can do. The only reason I decided not to do it tonight is because I'm not entirely certain like what the how-to is, and so like if we get, I don't want to get like to a point where it's like, oh, I need to order something to actually make it work, or I just can't figure out how to use it, and then the stream is kind of a bust at that point. So okay, or we're just gonna let that go because I don't see where I can turn off. I can't remember how to edit my chat setting in Restream so that I could disable maybe this one. Ah, here we go. So no, shoot. Okay. Yeah, I guess the only option I have is the not stream to YouTube, and that's not an option. So, okay. It's not an OBS issue. It's an issue with Streamlabs itself. Or not Streamlabs, Restream, because I use Restream. Restream has a bot sitting in each of the chats, and it's relaying the messages, and for some reason it's repeating everything that's happening on YouTube, and I don't know why. And I don't have a way to disable it. Yeah, it's not at all OBS. It's all handled by Restream, and I'm seeing it on their dashboard. So can electrolytic capacitors introduce high frequency noise? Not really. I mean, capacitors themselves don't necessarily introduce noise. They can be part of a filter, and it can the filter itself could have some kind of unexpected side effects, but I mean, caps themselves don't tend to introduce any kind of noise. Man, that is really frustrating. Because if both of these are doing it, then I don't think there's any. Yeah, there's just like there's nothing I can turn off. Oh, I know what I could do. I know what I'll do. I can just I think what we can do is temporarily block Streamlabs, which means I'll have to pay close attention. So I'm going to remove them as a moderator, and we're going to, let's see. All right, let me just take care of this, and then we're going to get started. Let me do this. Let me know how the music, just turn on some music. Let me know how the volume is. Wait a minute, that's not going to the right place. What is going on tonight? Okay. That is really strange. Okay, well, maybe we won't play music because it, oh, that's why. Okay. Okay, let me know how that volume is. That looks much better. All right, so Did he stop repeating? Loud, maybe? Okay. Yep, still repeating. So then we gotta go, and I gotta do one more thing, and then we'll be good. Restream bot. Oh, come on. No matching users found. Oh, why are you making this so difficult? I knew I should have copy pasted. Very bad bot. I swear. I swear. What I need is I need him to say something so that I can just block him. YouTube restream bot. Let me see if I can find. This might be what I want. Okay, we're gonna try this guy. I think this is it. Yeah, block that. All right, we'll see what happens now. And if that still doesn't fix it, we're just gonna have to deal with it. Because that's the best I can do. All right, hello to everybody. I'll just say hello as hello to everyone because let's get going. So let me hide that. We'll have that. Nope, restream is still able to. I guess I don't have a way to kick. That's the last thing I need to check. Is there a way to kick him out of the? I don't think there's a way to like kick him out, which is dumb. That's not it. Yeah, like I don't. It's not like, unfortunately, it's not like Twitch where I can actually see the list of people, and then I could just remove the one person. It's because he can still see what's going on in the chat. Okay. All right, we'll just I guess on the plus side is we'll have a lot of chat activity tonight without people having to work too hard. So, okay, let me move this over here. Try restarting the stream. Yeah, I don't want to do that. That's actually harder than you might think. Hey Tizboyo, good to see you. All right, so let's go to over here. And now, okay, so we're on Bit Preserve. Should actually be able to just go straight to it because I don't think anyone's submitted anything since Sunday. So let's go repositories, show and explore. We're gonna go Apple, Apple II. So one thing I've been doing, and that's because I'm a nerd, but the last couple of weeks I've been reading Apple II assembly books. I've gone through 2 vintage books that are written pretty well. One was written very terrible. The other is more of a manual, and it's not terrible, but it wasn't the sort of thing that it was more of a reference manual. And so until I write code, it's not going to really be useful. But one book was just, it was really bad. Like in 3 paragraphs, they would repeat the same thing over and over. And it was always really mundane things like file names can be made up of characters. And then in the next paragraph, it would say, so the characters for file names are what make up the name. And then the last one would be, here are examples of what you can put in a file name, which will use several characters to make the name. And it's just like, are you guys just padding this book out with words, or are you just a bad writer? Now, given that I've never written a book, I can't really, I guess I can't really criticize too much, but I can at least say it was very difficult to read it. So what we've been working on is this schematic from the Apple IIgs. So I have the original PDF, and part of the Bit Preserve project has been to convert this into a KiCad project, which is what we're working on today. And I believe we're getting very close to finishing the schematic. So I don't know if we'll finish it tonight. but we're definitely going to make a big step forward. You guys cracked me up. I'm gonna have to do it this way because I'll just have to look at these two, because that, since Restream is going to cause us problems today. G Brown, I'm somewhere. Hi, I'm somewhere. Babent with the dad jokes, of course. Oh yeah, how's that? I forgot, GB. You're working on that Mac Plus schematic. Are you frustrated because you're having a hard time reading it, or is something else come up with it? You know, I'm also gonna do, and I know this is kind of a bummer, but I'm gonna turn the chat off the screen, because I would be kind of embarrassed if my message kept getting constantly repeated, even though I was not constantly repeating it. So let's just turn that off for today. And I will just try to do a very good job of telling you who I am reading messages from. I can't tell what's worse, I made a dad joke or that you laughed at it. Yeah, I don't know. I kind of like dad jokes because they usually don't... You know how some jokes, sometimes it's like, even though you don't mean to be offensive or hurt somebody's feelings, dad jokes almost never hurt somebody's feelings, right? They're usually just really dumb puns. And so one reason I do like them is that they are a pretty safe joke to tell. The only real caveat is you might look, you know, a little silly. Okay, so this chip, UC5, which I did not name, so I'm glad I came and looked over here. That is our integrated WAS machine, which is how the Apple II accesses a disk drive. And the reason it's called the WAS machine is because Wozniak built the original disk controller for the Apple II. And it's a really cool design because he basically used some shift registers and ROM chips, and he was able to control the stepper motors in the drive. And so what this chip is it takes the state machine from that design and integrates it into a single ASIC. And so the way he controls the drive is basically through a hardware state machine, which is, I think, just absolutely clever. I mean, that guy is just, I don't know who else would be in that same league, but if he was not the best digital designer of his era, he had to be. And I don't know that there's been anyone that's as good at digital design as Wozniak was. So we see this is a 251, and I had a note to redo it. I think it's because I don't like the pinout. The thing I want to double check is, was this one that I made, or did I just find this somewhere? I found it somewhere. Okay, so we're going to go make one, because the pinout on this schematic is completely different, and I don't want to re-engineer all the pinouts. What did one dinner plate say to the other? Dinner is on me. I don't know what BOM arc is. So BOMARC, I'm not familiar with that. And if you don't know KiCad that well, GB, then redrawing a schematic is a really good way to learn it. So, okay, so let's go back to the project page, go into the library editor, or symbol editor. Gotta wait for it to load. This library was not found. Oh, okay. Now I know how to fix that. Let's go fix that right now, because that keeps happening and that's annoying. So we'll go into manage symbol libraries, and in here I should have this one, which we're going to take out. I'll just set it to inactive because I might still have this file somewhere. This is a chip that's actually for a what is it for? It's a USB-C power controller, and eventually we're going to make a cool thing with that. But not today. Okay, so we're going to, you know what, I'm just going to create this from scratch. I was going to copy and paste the other one, but screw that. Let's just do a new symbol. Symbol name is going to be HTC251. It'll be a UD designator. Okay. Move that down. Maybe one more. Zoom out. Let's add a pin. And we'll add a pin name G. And that'll be pin 7. It will be inverted. And I want it to go yeah, like this, right? Yeah. Okay, and then down here we'll do A11, and this is going to be regulared. And here we'll do pin name B10, and here we'll do C9. Skip a couple, and then let's do D0, and that's 4. Let's do this guy, and that's going to be D1, 3. Ooh, that's loud. Jesus. Okay, it was somebody calling my Google Voice number. It was definitely spam, since since that's all that really gets that number is spam. All right, D1. Let's go D2, and that's pin 2, and then we'll do D3, and that's pin 1, and this will be D4, and that's 15. That's D5, and that is 14. And this is D6, and that is 13. This will be D7, and that is 12. 0, 1, 2, 3, 4, 5, 6, 7. And then we're just going to have 2 pins over here, somewhere around maybe like right here. And this is going to be Y, that's 5. And we need to make that go left. Even though it's on the right side of the pin, the direction in the direction in there is left. Okay, W, and that's 6, and this is going to be inverted. So we'll do that, and then we'll draw a nice box around all of these. Something like that. Then I can right click on this, or hover on this, hit edit, fill with background color. I like that. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yeah, that looks close enough. Go there, go there. All right. Is that an 8-bit parallel bus? Yeah, I mean, most of the system's going to be 8 bits. Even though I take that back. The 2GS is actually a 16-bit system, but it's backward compatible with the 8-bit of Apple II. And this interface for the disk controller, I'm pretty sure was all 8 bits, since it was all in the Apple II timeframe. Oh, okay. I didn't know that's so. Ballmark made their own versions of the Apple schematics. Okay. Oh, and they did it by reverse engineering, huh? I see. Yeah. Sorry, Geek Boy. Didn't mean to well, actually, that's why I tried to mute it, was because I didn't want somebody to think it was their phone ringing. It just took me a minute to realize what was going on, because I just recently turned it back on, because when I was moving, I ended up giving out my phone number to a bunch of services, and I was giving them the Google Voice number, which I normally don't even have ring, but because I was sort of using it to communicate with people, I was like, yeah, I guess I better enable it. I'm probably about at the point where I can turn it back off, though. Something doesn't look right. What's going on? Those pins don't look right to me. They look too short. Shoot, they are short. Okay, so let's go ahead and right click, properties, library editor. That's why. That's held over from the last thing we did. Just make these a little bit longer. The pin longerer makes me think of Futurama when the professor invented the finger longerer, and he said he's like, oh look, I can make my finger really long so I can turn things on from a long distance. And then somebody's like, well, what's the thing that you're turning on? Oh, that's my what if machine. It can recreate reality with a single change. It's like, okay. He was so cool. Always inventing cool things and not realizing the value of his inventions. My favorite, though, absolute favorite, was the death clock. And so it was supposed to tell you when you would die. And somebody asked how accurate it is. He said, well, it's accurate to within a few seconds, what with free will and all. I just think that's so funny. Anyway. Alright, so this is going to be an easy one. That's a no connect. Oops. Let's do no connect. There we go. Then let's get a label going. That label's going to be MD bus 7. That over, hit G, move that over just a little bit more, get some room going, and then let's see what these other signals are. So we got CP3H, CP2H, CP1, and then we're going to have some pull-up resistors to go along with them. Okay, so let's sort of plan out something similar to what they did, because we'll probably end up in a really similar situation. And I'm going to copy that and then come to, let's say, there. Copy this up to here, and then copy this. Run out of space. Copy that to here. That's going to be CP0.H. Okay, not quite symmetric. My buddy uses a phone number from a different state that he has never lived in to filter out spam calls. Actually, both my real phone number and my voice number are from when I lived in Texas, and I haven't lived in Texas for 6 or 7 years now. And so it's funny because those of you in Discord know that I'm a big fan of Kit Boga. He's the guy that calls scammers. And one thing that almost always ends a call right away is if he says he's from somewhere that his area code doesn't match. And it's because in the US, it's really common for people to keep their cell phone number when they move. So the whole concept of area codes have sort of become irrelevant, because it doesn't really indicate where you are anymore. And so it's always interesting, because it really upsets the scammers, because they think that it doesn't make sense that somebody that lives in Illinois would have a Texas area code, whereas that's actually a really common thing. I mean, like I said, for me as an example, I haven't lived in Texas for 6 or 7 years. Maybe it's 5 or 6 years. No, 6 or 7. It's been 6 or 7. And I don't really see a need to, get a local area code. Why would I? I should have. This looks like 86, 85, 84, 80. Oh, you know what we're gonna do? I know what I'm gonna do instead. I already see what these are, just pull-ups, right? I think there's a better way we can draw this. The death clock doesn't work on an 8-bit bus. Well, if the death clock existed when the 2GS was out, the death would have been predicted to be somewhere in 93 or 94. That's why I still have a 1-800 number. You have a 1-800 number, GB? That's kind of... That seems like that should have a story associated with it. So what I'm thinking we're going to do is, what if we just put these like right here, and then we just tie these all to 5 volts. It just feels like it's going to be cleaner. Maybe not. Okay. So we got to move these over. These are going to end up getting moved over, because then we also need room over here for whatever all this junk is. C06067-L. Okay. All right. I'll move these back just a smidge. So I was telling you, let's see, I got that machine learning board, so I'll be playing around with that. Like I said, we're going to do that on Sunday. And then the other thing that came in, and I'm really excited about, is the PCBs for the sensor that we designed a couple weeks ago. Those came back. And so last night I ordered parts for all of those, and so I think we'll get parts by next week. But either Wednesday or Thursday next week, we should be able to start putting that together, which I think will be fun. Okay, so D0 actually goes to a label called SW3. So let's go grab that. Maybe my original idea will work if we can label all of these. So pin 3 comes over here and it goes to SW0 Opal, SW0 Opal, all right, and then pin 2 goes to SW3 Capel. Oh nope, it's SW1 Capel, and then 1 goes to SW2. Interesting. Then what we could, I think what we can do is, what if we moved... Oh, well, you know what we can do? We'll just leave them like this. We'll just bring these to roughly here. And I'm going to move this to all be aligned. And then we're going to do a wire like this. Back and connect those. Beautiful. And I can go one up, over, and then connect. And let's get a 5-volt signal. Plus 5 volt. Beautiful. Yeah, with how phones work, it's not really an area code anymore. It's not some magical branch. Yeah, I mean it's really not even a prefix, I guess. I mean phone numbers are essentially IP addresses at this point. And well, that's funny because even IP addresses originally were supposed to be routable, but new routing tables or modern routing tables are so messed up that they're not nearly as clean as they once were, with all the subnets that got sold and moved around. Problem with the schematics is that the bus lines are hard to decipher from the BAT scan around the processor. Yeah, I can totally understand how that would be an issue. I mean, that was why when I first thought of the bit preserve project, a lot of people kept trying to tell me just to use Python and OpenCV. And it's like, look, even if you give it a machine generated schematic, like we gave it this schematic, it would have trouble identifying it. And then you look at some of the scans of the PDFs that were available, and there's no way that a machine would be able to decipher some of them. Excuse me. It's a long day at work today. Did not get a chance to relax much. All right, so we're gonna do this. Need to add some capacitors, 0.01s, so they're probably ceramics. So we're gonna do like one here, maybe do one around here. This one, C34, edit this one. Oh, I forgot I was gonna show you guys a picture. I got so distracted with the chatbot being a pain. So as I said on Sunday, I expected my benches to arrive on Monday, and they did. And so right now, the lab slash studio slash basement is basically full again of boxes, which is a bummer because my mom and sister did such a great job on helping me get rid of the boxes, but there we are, here we are again. And I started putting them together. So I've got the first bench is halfway done. And now that I know how they go together, I should be able to get the second one done really fast. And it's basically, there's the bottom bench part, and then there's there'll be some basically poles that go up where I can put the shelves and stuff. And so I'll be doing that later. What I really need is a horizontal bandsaw, because the shelving unit, the shelving like posts that I got are the only ones that the company sells, and they're about a foot longer than what I really want and need. So at some point I'm hoping that the makerspace that's not too far from my house opens up, and I can get in there and cut a foot off of these metal poles. But other than that, I'm really excited about the bench. So funny story, I started putting them together, and I got to a point where it's like, oh, and now put the stringer here and here. And I was like, but there's no stringer. I looked through all the boxes that I had opened up at that point, and I double checked all the other boxes and their names, and I'm like, I don't believe this. This is missing. This is like missing a part. And the way it works is, from this company, you basically buy all the pieces you want, and then you just kind of put it together. And so it's sort of like a professional version of IKEA, but with a lot more flexibility. And so what I thought is I must have forgotten to order some piece of the bench. And then I went and looked at my order and remembered, no, it was because I replaced the original stringers with ones that have power outlets. And that's when I noticed that not only do I now have extra AC jacks, but they also have a USB-A and a USB-C power connection. So it's a very modern lab bench. I'm really excited about that. Probably more excited than I should be, but that's okay. Are you planning to make just a schematic, or are you doing the layout too? I have no plans to do the PCB, and there's a couple of reasons why. The primary reason is I think the PCB would require basically redrawing the actual literal PCB, and to me that's not all that interesting. I actually think that that's a really good option for something like OpenCV. I also think, or there are also services where you can send them a circuit board and then they will basically scan it, sand down a layer, scan it, sand down a layer, scan it, and then generate Gerbers from that. And frankly, I think like if you had a set of those Gerbers plus say this schematic, you could probably do some kind of computer vision capture and basically recreate the circuit board layout from that. But the reason I wanted to do the schematics is because schematics are a description of the circuit and the circuit board. So we have some liberty that we can take with how we draw it. We don't have to be one-to-one perfect. Recreating the circuit board, to me, would be really, I mean, it would be a good exercise if you want to practice doing a PCB layout, but it's basically just artwork, because to be useful, you would have to duplicate the PCB exactly. There would be no room for artistic license or making the schematic more modern or the design more modern, because to be useful, you have to copy exactly what is there. And so I think it's just, I mean, I can understand if somebody else wants to do that work, and I would totally support it, and I would be happy to make it part of the project, but it's not something that I have any interest whatsoever in doing. That's weird. This is a pull-up resistor, so I could have just done this. So that was a really long way for me to say, no, I'm not going to do the circuit board. But like I said, if somebody else wants to, I'm totally okay with making it part of the project. I just, it's not something I'm interested in. And then, let's see, so this was R2. This was 200K. This is going to be, looks like SW3 also gets pulled to 5 volts. That's R1. That's also 200K. So except in microwave runs. Wait, I missed when you said that, Geek Boy. What was the microwave comment towards? I see there's no value in it for the channel. Well, actually, I think it'd be interesting for the channel. I'm just not interested. I mean, I think there could be value in seeing it. I don't think it'd be. I just don't want to do it. Instead, what I want to do is get to the next stage of my project, which is to build a portable Apple II, which is what kicked off this whole project, because I need one of the chips from the Apple IIgs to do that. And so what I'm more interested in doing is getting this schematic done and then moving on to the portable Apple II. And I think designing that circuit and that circuit board would be a heck of a lot more useful to people. But yeah, I guess the other thing I wanted to say, because I don't remember if I've said this before, but you can debug a circuit board without knowing where the traces go, if you know what the schematic of the board is. And so it's much easier to sort of work it out in that case. Wow. This is a Social Security call. I should actually answer that one, because that one's really funny. I think it's funny because if you've ever watched Kitboga or other scammers, when they do the Social Security scams, it's always that a car has been found on the south border of Texas that has 20 pounds of cocaine in it, and it was rented with your Social Security number, which makes no sense. You don't rent cars with a Social Security number, so there's no reason that the Social Security Administration would ever call you about it. But the reason it's funny is because they ask you, have you ever been to Texas? And if you answer yes, they almost always hang up the call, because part of the scam is they want you to believe that somebody has rented a car in your name. And so if you make it sound like you've ever done it before, you're going to be harder to scam. Well, I think it's funny because they're calling my area code, which is Texas. And the 2 times I have answered the call, they say, have you ever been to Texas? And I say, yeah, I live in Texas. And they immediately hang up. So it's like, why are you robocalling people in Texas if you don't want to talk to people in with a Texas area code if you don't want to talk to people in Texas? I mean, that's, I don't know, seems kind of dumb. Okay, so we got these two resistors. This signal connects over here. CA, this thing all connect into a bus, and then that bus, let's see, where does this signal go to? Okay, we need to actually, this one we actually need to do a global label. I'm gonna do it over here, and that's gonna be C06067.L. Then let's do a test point. Like maybe right there. Go over a little bit. But the scams actually seemed to calm down for a while. I don't know if you guys noticed robocalls had started to drop off, but I noticed in the last week they're all ramping back up. I'm getting about one robocall a day, and so now this was my third one today. So debugging a circuit board without knowing where the traces go is mostly possible if it is proven to be working. But when their prototype first runs, it can get really messy, especially on high speed. Yeah, and anything, I mean, I guess the one other caveat I should say there is if it's a multi-layer board where there are strip line traces running, then that becomes really difficult. At least with top and bottom layers, you can sort of see where the layers go. But if anything goes into one of the middle layers, yeah, that gets really tough. But again, if you know what the schematic is, you can sort of work out that this pin on the chip and this pin on the chip should have a connection somehow. And so you can at least work that out. But if you don't have the schematic, then that's going to be really tough. And conversely, if all you have is the circuit board, it's not enough to know which signals should be connected. I mean, you really need the schematic to be able to tell what what is correct. So all right, so we got that, and then this bus comes up here, which I'm not going to worry about at the moment. Oh man, I do not know what's going on. Okay, so we got to do this. It looks like NE558. And I think I tried to use one that was in the, let's see, what is missing? So this has pins 3, 6, 11, and 14. And those connect to something called PDL trigger. So I wonder why this symbol doesn't have those. Huh. Let's see, is there a different one that we could use? Oh, I drew this one? Oh, well then I drew it wrong. Yeah, I drew this one. Okay, well, I wonder if it's getting used somewhere else. That could be what's going on. Actually, you know what we can do? Let's just go to GitHub. Hit preserve. And then search for NE558 and see. So it's on page 4. That's where we're at now. It's in the rescue library. Not worried about that. That's the regular library. That's the cache. And then that's another cache. Okay, so we can replace it. Yeah, I don't know why it's drawn in, why I drew it incorrectly. That's kind of lazy on my part. I don't know what that's about. Let's double check. 2, 5, 10, 7, 4, 12, 8, 9, 16, 1, 5, 13. 4, 12. Okay. So let's move this one over here, this one over here, and then let's add a pin. We're gonna go. Okay, we're not gonna give these names. I'm gonna do. I got a plan. This probably move down. Right. Nope. Yeah. Oh, is this still on inverted? That's why I'm getting messed up. Okay. So we're gonna do 3. And then let's do 6. Let's do 11. Nope, that was the name. Ah. Let's do 11. Then let's do 14. Yeah. Yas. All right. Get this and this into here because these are all going to go on top like this. And I'm going to get a little text label here. I'm going to go triggers, the name of my horse. Make that 1 millimeter. Do that. Triggers. There we go. Much better. You should breadboard this circuit you're making. Yeah, I won't be breadboarding it. However, it's not going to be a total shot in the dark. I will be taking the chip that I need. I'll actually be building some prototype boards that will work from, and basically go about it from that perspective. And so what we'll do is we'll make like breakout boards for the various chips, and we'll sort of breadboard that, so to speak. And then from there, we'll do a real circuit board design for it. The Mac Classics are dual-sided boards. They have components on both sides of the board. Yeah, that makes them tough. But I would expect that the internal boards are multi-layer, because I think the 2GS was definitely at least a 4, if not 6 or 8 layer board, and I think the 2E might have been the first non 2-layer board. But it's either the 2E or the 2C is were the first Apples that switched to being multi-layer. Babbitt. Sometimes I'm like, who wrote this code? Yep, it was me. Yeah. Or you, not me. Okay, save that. Let's close this. Why do you keep doing that? I want the labels over here. Okay. So what do we got going on? There's like all this mess of stuff. So let's see if we can't maybe make some sense of what's happening. So triggers all connect to something. What? They just all connect together is what this is saying. And then they go to PDL trigger. Okay. So that's kind of easy. You can just kind of do one of these. Put a label down here and we'll do PDL trig.l, and then we'll grab a test point and we'll just kind of do, let's do this. I'm going to name this TP11. Okay. Copy this, edit this, paste that. That looks good. Which I can actually, what I can actually do then is probably just do that. Oh, do that over here too. Okay. Now, how are we going to get the rest of this stuff? Okay, this is easy. This is going to go to 5 volt. Oop. Okay, copy that. And let's go ahead and get a ground. GND, ground. Okay. And then we need a capacitor. And this, we're going to move the label over to this side and label over to this side. Wire that up. And then let's wire up this ground. That looks really good. This song, I am not happy with this song. Need something with a little more beat. Beat. You have a horse? No, I don't have a horse. It's from a 80s song, I Want to Be a Cowboy. And there's a lyric in there where it goes trigger the name of my horse. Yeah. Okay. What's wrong with the world? It's 9 p.m. and the sun is still out. Or it's summer, right? Isn't it summer? Or I guess it's summer in a couple days, isn't it? Okay. Forum posts as well. GB, I just saw that. What idiot said that? I have totally found myself as the recipient of that experience where somebody will quote something from the thread and say, well, you know, I'll see the quote and I'll be like, oh my God, what idiot said that? It's like, oh, that idiot was me. I said that. It's like, well, we'll just say that I learned over time that things were different than what I thought originally. Okay. And then they want a label in here too? Come on, really? Why? Why is this labeled? I don't, give me one good reason. 2E84. Because that just makes it so messy. So messy. Whatevers. Okay. Let's come up here. So UE8 2. This over. Let's try UE8 15. Copy this. 10. Copy that. 7. All right. 8, 2, 15, 10, 7, 2, 15, 10, 7. My eyes just like went crazy trying to figure out what all this stuff is. That's gonna be fun to figure it out. Let's see. What about the output side? That looks a little less daunting. So output connects to the signals from before. Awesome. So let's just bring these down here. So DA or OA. I was gonna say DA, but I guess it's OA. OA. That is CP0. So we can do something like this, and then OB is CP1, and then 2, then 3. Yeah, check that out. Okay, so 0, 1, 2, 3. And then we need a whole bunch of test points, apparently. Which, you know what we're gonna do? We're just gonna put the test points up here where we have room. It makes a heck of a lot more sense to me. Like we can do like this one, this one, this one. Okay, that one's a little messy, but we're gonna make this work. Okay, and then I'm gonna move this up here, which I should have done this and then copied it, but whatever. Have to do it the hard way. This is gonna be 15, and then 16. Okay, then let's move these back up. So I'm using the G command, which has become one of my favorite commands in the schematic editor. It just makes cleaning stuff up so easy. This up to here. This is 18. Okay. Yeah, that works. That's a heck of a lot cleaner than whatever they had going on over here. Okay, let's save that. Did you like working for a capacitor company? What was that like? It was interesting. We had 10,000 employees. Of the 10,000, 1,000 were engineers of some form. And of that 1,000, less than 100 had an electrical engineering degree. So most of the technology and science, what I'll say, most of the technology was around chemistry and material science. And so there were very few people that actually used capacitors. And so it was just it was unique to me how there were experts on the physical capabilities of a capacitor, but very few people knew how to design them into a circuit. And so it just made it made it for an interesting experience. And I would say there's what I really liked about working there had nothing to do with any of the technology. It was the people that I worked with. I got to meet some really cool people that I still talk to almost every day. So I made a lot of really good friends while I was there. But the thing that we used to joke about capacitors is that they are like the toilet paper of the electronics world. Nobody cares about caps until they do, because they run into a problem and then they care, or that nobody cares about caps until you realize they're not there, and then it becomes a very serious issue. Just like if you realize toilet paper is missing, that's a pretty serious issue. So, oof. And somehow we're going to get a capacitor to come around. 2 goes to there, and then it's going to come down to here. I'm not seeing a really clean way to do this. I know one thing we're going to do. We're going to spread out these signals on the chip, on this symbol. There's no reason that they need to be clumped together. Why do you prefer KiCad over other CAD software? Well, number one, it's free, so that's a pretty compelling reason. But as I often say, just because something is open source or free is not the only reason I use something. And the fact that it is open source isn't really the reason I use it, although that certainly helps. But it's free, and it has what I would say is as much capability as most commercial software. So there's that. I mean, except for high frequency like serial data or RF stuff, KiCad isn't really lacking much in terms of features or capability. The only other area that bugs me is they don't really have a good library or BOM management. So like what I would really like, and I've seen it I think in Altium, where you can basically define the library of parts that you have, as well as, so like if I need a 1 microfarad capacitor, instead of selecting the symbol and then saying capacitor 1 microfarad and then finding a part number, when I go into my library, I would actually see the inventory of part numbers that I or my my part store, like wherever I store my parts, what's available. And so KiCad's really lacking in that area. So in regards to the microwave stuff, the next version addresses some of that already. So I'm glad to see that. That's actually the one area where I'll say that I'm glad that KiCad is open source, because the amount of people working on KiCad is significantly larger than like if I look at the amount of people working on Eagle. And so if I look at the major revisions of KiCad over the last 3 years, with each major revision, there has been significant steps forward in usability and capability. Whereas if I look at, say, Eagle, they've made some steps forward, but nowhere near like the order of magnitude that we're seeing with happen with KiCad. So number one, I use it because it's free. But number two, well, actually, number one reason I use it is because it works. I'm very much a proponent of use the right tool for the job. So it works. But number two is it's free. And so if I have a tool that is free and works really well for the things I do, it's going to be tough to get me to move away from it. So, okay, so for these caps, I think what we're going to do, it's kind of funny from a convention, but I think this is a compact way to do what they're doing, because basically what they're with each of these, we have a wire, and then that goes to ground. Goes to chassis ground. Okay. Now, backing up, for the purposes of this project, Bit Preserve, where we are recreating the schematics for vintage computers, that's a case where a open source package, I think, or open source option really matters, because then the barrier to entry is very low. You know, if we used a commercial software to do this project, then it would have limited the number of people that could actually contribute, because not everybody could afford the software. And so that would have been bad, because that would really go against the whole idea of the original project. So, and I wish I had done that before I copied and pasted this, but oh well. There we go. Then let's see now. So 24. So 25 connects to 15. And 27 connects to 7. And 26 connects to 10. But then we need test points to connect to those. Shoot, I really shouldn't have copied that so soon. How fun would it be if you got the schematic right the first time? I tell you what, now that we've spent so much time on this schematic, I wouldn't mind if we got a few things right the first time. That would be okay with me. So, what program do you prefer over KiCad? I don't really have one that I prefer. I haven't used any other commercial software in over 5 years. So I can't really. I wouldn't compare any of my previous experience, because it's probably not valid anymore. So. All right, let's put that here. Oh, come on. We ran right into those resistors. We're gonna have to change the size of this page too. We had to do that the other day. Yeah, I'm gonna bring this down here just so it's clean. Okay, so 65 connects to 7. And then 64 connects to 10. 15 connects to 63. And 2 connects to 62. Yeah, that looks good. Okay, that wasn't quite as painful as I thought it was going to be. Save that. We're going to have to rearrange everything in a little bit, but let's get everything drawn and then we can figure out where stuff is going to go. So these are all 100 ohm resistors. So let's place those. This is R79. This is R80, and then 81, and 82. That didn't happen. All right. C25. Thank you very much, AJ. That is now corrected. Yeah, that looks good. TP or switch, TP15 is on CP0. Okay. Oh. Thank you for the pickup on that one. Yep. Let's just double check that, because then 18 connects to that pin, and if we come back up here, it is CP3. Yep. Okay, thank you. What is the difference between normal ground and chassis ground? Chassis ground is usually connected to earth mains. Yeah, as said in chat, chassis is literally the chassis. Usually you want what you really want, like in the digital port part of a circuit, you want everything connected to the same ground reference, and then that ground reference should be connected to what other ground references you have. And you can usually do that through like stitching capacitors. So thought being bald was a requirement for an engineer. Yeah, something about thinking a lot and doing math causes your hair to fall out, I think. Because I started losing mine while I was in college. So Okay, so that's looking good. We got these test points basically covered with this stuff down here. Can we move all this stuff up? See if I can grab all of this and just kind of nudge it up a little bit. And then let's see. Nope, I don't want to grab the other stuff. Can we just get this part of the circuit and just kind of do this? Then get this up into here. Maybe what we can do. Nope. Okay. What I really should do is like do something like that, and I can move this up here. Yeah, that's a little bit better. Okay, that's looking decent. What's all these resistors? Where do they connect to? So we got PDL 0213. Okay, that's all going to connect to this game port, and then this connects to a PDL signal, that connects to a PDL. So I think we'll be able to do this through PDL or through labels. These look like copies from the other signals that were up here somewhere, or maybe. Oh, I remember. Yeah. They're copied from up here, so we'll be able to do that. Ah, Jane D. Vasco, thank you for the follow. Welcome to the stream. C128 is 0.1, not 0.01. Yeah? Oh my gosh. Good call. How did you catch that? Huh. Well then, since that is what it's supposed to be, we will change it. Wow, I wish I hadn't done that. Yeah, I don't like that either. That's gonna look better. Okay, so I think what we're gonna be able to do is let's just grab a 9-pin, and then we'll just be able to, I think we'll be able to do labels for most of it, and then we'll add some labels to this one, and then this section might be good to go. All right, let's save that. Wide monitor or double monitor? Both. I have a large display that you guys are seeing that is actually, it's a 4K display, but I have it down to 1920 so that it doesn't scale funny. And then on the right, I have a portrait mode widescreen monitor because I used to have landscape next to each other, and then I realized that if I put a portrait monitor, I can actually stack a lot more stuff on top of each other versus what I could stack along like this way. So yeah, it's turning out I like having my second monitor be turned 90 degrees. The only time it's not as nice is when I'm like, if I want to watch a video full screen, I only get like, you know, part of it. But for the most part, like having like Discord, my email, Spotify, and stuff like that, it actually works a lot better. Well, let me re-say that. It works a lot better for me. I don't know that it would work well for everybody, but it works great for the stuff that I do. Oh yeah. Okay. I'm going to, you know what I'm gonna do? I'm gonna go grab something to drink, probably with caffeine in it, and maybe get a snack because I'm a little bit hungry. So I'm gonna take like a 2-minute break, and then I'll be right back. So let me throw trivia up, and then I'll be back in just a couple minutes. I might also turn my air conditioner on just so that it's keeping me cold. So yeah, so I will be right back. Okay, so I saw a comment that got my attention. Oh, AutoMod. So Jim FY. So hey, thanks for you actually reminded me of two things, and I forgot to mention them. So let's take a momentary break from the schematic, and let me show you something. Let me show you guys something that I'm pretty excited about. So let me open this up. So first off is oh, and I can't see where I'm at. So first off, this is the condition of the new lab. So last Friday we did a live stream from the lab, and so I was actually standing where the camera is right now. But what you can see in the background is I'm setting up the workbench. Like I mentioned, I've got two of these, and I'm halfway done, so that's half. So tonight when we finish the live stream, I'm going to go and put the other one together. And then I've already realized the way I was going to set these up I don't like, so I'm going to change, but I'm pretty excited. And so like all of these boxes are just pieces for the workbenches, and so that's taking a little bit of time to get those set up. But yeah, that's kind of the current state. It was super clean and nice, and it was really kind of not. I was working down there a couple days during the week, and now it's just in total disarray. So oh, okay, gotcha, Jim. Now I understand your name. So yeah, so I got that going on, and then the other thing, and I think if I come back to my other scene, so there's two people that are very active in the AddOhms Discord, which if you want to keep the conversation going, you can go over to addohms.com/discord, and that will actually, second, go over to YouTube. I don't think it is. You can join our Discord server, and there's two people that are very active there who took some code that I originally wrote for this multimeter, which has Bluetooth or BLE, Bluetooth Low Energy capability, and they created, this is set up. Oh no. No. Oh, James, fail. Oh. I just realized this is the wrong OBS instance. So I don't have, okay, I think I can recover really fast. Oh man, I can't believe I get this all set up and then it's like, oh, except I can't show it. Let's go browser, on screen, DMM. All right, stand by. Check this out. Okay. I need to know one more thing before I go click this. BLE, DMM, GitHub, Bald Engineer. This reveal would have been so much better if I was like, prepared. Okay. 250.85. Okay. Say okay. Then let's kind of do one of these, something along these lines. So, okay. So what we got going on is whatever's on this display shows up on screen, right? Which I think is pretty cool. So what we're going to try to do is I'll hold one of my leads over here in my hand. See I don't know if you realized it, but the camera in the picture that I just showed you was my, let me take these off, that's what's going on, is my normal overhead camera. So that's why I can't just switch to overhead right now, because it's downstairs. Okay, so I'm going to hold this up. I'm holding one lead with that behind, and then as I hold my hand, and then that way, the cool thing about this now is when I'm doing stuff in the overhead, you'll be able to see the multimeter results without me having to keep the multimeter in the frame, because it's really hard to like zoom in on a circuit and then have this thing show up so that you guys can see it. And so I'm really excited about this because I think this works really, really well. And I think Tizboyo and Geek Boy or Geek Boys Boyzoo did an awesome job. So let me do a quick thanks so that you guys could also say thank you to them, because without them, I could not have gotten that to work as well as it does. No question, zero. Like, first of all, it would have been another year before I ever got to it. And what they did with this stuff, it works exactly like I want it to. So yeah, so that's really cool. And I think in the next, so I think with some of the upcoming streams, especially when I finally get back into working in the lab, we'll be able to make really good use of that. So okay. So where could I get one? Yeah, okay, thanks, Geek Boy. Yeah, so it's so they're sold by Newark, which so as many of you might know, I actually do videos for Element 14 Presents, which is owned by Newark, and this particular meter was given to me for free. However, not paid or endorsed to say or use it. However, it was really funny because I had decided to start doing weekly streams, and I was getting much better about it. And then they contacted me and said, hey, would you be interested in reviewing a Bluetooth DMM? And I was like, as a matter of fact, I would, because I need one. So yeah, so cool. And they're actually relatively inexpensive. The only thing I'll say, and I ended up not actually doing I didn't actually do a review on them. Instead, I just did I think DMM Basics video. That might have been the one I used. The only thing I really don't like about it, there's two things. I shouldn't say only. There's two things I don't like. The first one is it doesn't have a min-max function. It has a hold and a relative, but it doesn't do min-max. And I really like min-max when you're like trying to say like measure, like if you're trying to poke into a really tricky spot to measure the voltage or something. It's just kind of nice that if you get a really good connection that, you know, it'll hold that, whatever that maximum value was. So that bothers me. And then the other thing, and this is super petty, but all of the micro multi-comp pro and 10 meters from Newark, they all do this, and it drives me insane. They beep before they turn off. And I suppose for some people that's helpful, but I really wish they would just shut off, because I'll leave, I'll stop working, and then I'll be working on my computer, you know, or like writing up my notes or something, and then it beeps and scares the hell out of me. And it's like, just shut off. My Fluke shuts off when it's done. It doesn't make any fanfare or any noise. It just goes to sleep. So those are the two things I don't like. In terms of accuracy and reliability, as far as I can tell, as far as I can tell, that one is pretty good. So all right. Except I don't know that's I would just got myself totally confused. So this one, yeah, okay. These I don't know what I'm doing. That's because I was talking instead of doing stuff. Oh, thanks for sharing the article too. Yeah, actually, I need to do a follow-up because I want to tell people about the stuff that you did. It's in my list of things I need to do. Having something like that for distance learning. Yeah, so just to fill in the blanks, and I'm sure Geek Boy can help out, since he can probably help out a little more detail in the chat. But just a real quick heads up. So so right now everything we have is based on Python. So what you saw on screen is basically HTML and JavaScript, a little bit of CSS. But the back end is all Python, and we're using a module called Bleak, which is really nice because Bleak provides a BLE interface on Linux, Windows, and Mac. So I have been able to test this meter with at least one Windows 10 machine, 2 Macintoshes running various versions of Mac OS, and then Linux on a Raspberry Pi. And so Linux on the Raspberry Pi and the Mac work super easy with these meters because Linux, BlueEase, and all that stuff works well. Windows is a total pain, but the Bleak module totally makes it much easier and more reliable. And so the backend is Python, and then it spits out to that web page. If you follow the link that was, I think, did you post the GitHub link? You did the Workbench Wednesday link. Let's just do emple bald engineer. There it is. So this GitHub repository, has the Python code, and I think it has all the web code that Geekboy wrote, and then there's directions on how to get it up and running. Not really difficult. The way that I'm doing it is my streaming computer doesn't have Bluetooth, so I'm actually connecting to a Raspberry Pi, and the Raspberry Pi is providing the web interface. It's running a web server, and so it's also doing the Bluetooth. It's also the server that runs the trivia. So, just a fun fact. Anyway, I'm gonna get back to the circuit now. But yeah, I was so excited when those guys showed me what they were working on. They pulled me into a voice chat one night and were just like, "Hey, is this what you had in mind?" And I was like, "You've got to be kidding me," because, like I said, it would have been forever before I ever got to it. So, and I think it's gonna make it. It's really gonna help out when we do some like in a couple of weeks when we not weeks, like next week even, when we start to put together the sensor shield that we worked on before. It's gonna be really nice to have a multimeter available. All right, so let's get this one on here. And then so 10 and 11 are gonna be chassis ground. Okay, GND ref. Put that there. Oh, I don't have plane, is this stuff. There we go. Again, let me know about volume on the music. For whatever reason, I'm not able to route volume control and hear it. So, although I just realized how I could have done it, and maybe I'll need to do that. I'll do that some other time. But I just realized why I had things set up and then I broke it. Don't you like that? When you change some kind of setup only to finally realize why you made it that way in the first place. I just realized why OBS was set up the way it was. And when I saw it, I'm like, yeah, this is wrong. Nope, it was not wrong. It was right. PDL3. And then we'll go PDL1. So PDL must stand for paddle, right? Or maybe, let's see, the Apple II actually used analog joysticks. So maybe PDL is really meant to be like the potentiometer directions. And then 2 will come up to, uh-oh, that doesn't look right. 2 is connecting to pin 4, but I'm on pin 5. So what did I miss? So 10 and 11, and then 9 goes to 3, 8 goes to 1, 7 goes to Opa, 6 goes to something else, 5 goes to something else, 4 goes to PDL2. What? And where's PDL0? Right, 4 goes to PDL2. But PDL0 goes to 5. Okay. It's because 6 goes somewhere else. Yeah, feel free. You probably definitely know how to use GitHub way better than I do, so I'm still learning. right, 3. Okay, so 3. So we got 1, 2, 3, 1, 2, 3. 3 goes somewhere over there. I'll go find that later. Let's go ahead and fill in these others because then I feel more accomplished. All right. Actually, on my list of things to do has been a tutorial on how to use GitHub for hardware engineers. The problem is I don't know how to use it. So, I mean, literally, like, one of my thoughts when I started this project, and Babbitt can confirm because I talked to them about it at KiCad. I was like, one reason I want to use GitHub for this is because I want to have practice with multiple people contributing to a project and managing that on a GitHub repository, because I've never done that. And usually my GitHubs are, I commit something after I'm done because I just want to have it like archived somewhere. It's like I'm not actively developing through GitHub. And so one of the real big things I want to get better about is, like, when I'm writing Arduino code, to even locally start using Git to save the code when I go and change things. Because right now I'm more of a, I'll just do a file save as, or you know, copy and paste into a separate document. And that's just a terrible idea. What in the world? What in the world? Did you guys, oh my god. Oh, you're not going to be able to see that now that I check this out. We might highlight this just because this is hilarious. I cannot believe how far this signal runs across the schematic. Why didn't they just label it twice? Is GitHub on the KiCad feature list? What I can tell you, and this was a year ago at KiCad, over a year ago now, it came up several times with the lead development team how incompatible KiCad is with GitHub. And so one of their takeaways was that they had to relook at how they manage some of the text files, because they know that they were changing things that were causing Git to get cluttered. And so they were looking at how can they do a better job of that. In terms of like integration, I have no idea. I don't remember them talking about that. I don't even offhand know if that's a good idea. But yeah, it was, at least the development team was really aware of the troubles that people were having with KiCad and Git. Okay, so check this out. Oh, that's huge. How do I change that? Tools. Edit PDF. Nope. Oh god. This is one thing I really missed from the Mac is the program preview is so good at editing PDFs. Like, I don't even know what it's doing right now. Hey, Ant Pirate, I just saw that you were in the chat. Nice to see you, man. Okay, come on. All I want is to change the size. What do you... Oh, why are you going to pages? I don't... Stop it. Stop. You don't need to... Oh my god. Why you gotta be that way? You know, Acrobat, this is why nobody invites you to parties, is stuff like this. You know... You ever notice when you get on the voice chat and everybody leaves? It's because you do... Stop it! Oh my god. I don't want you to recognize the page. If you could recognize the page correctly, I wouldn't have to do this in the first place. Okay. So... Now where did my highlighter go? Oh, this drives me crazy. No. Oh my god. Oh jeez. Wait, was that actually what I wanted? Yeah. I want this, and then I want this, and I want to make it like, okay, that was way more effort. Okay, all this because I just wanted to show you guys how far this signal travels across the schematic. This is totally not worth it anymore. Okay, so this signal comes down. Okay, so that's pin 3 on here. It comes down around here, and then it goes all the way down here, all the way across here, up here, over here, up here, over here, up through here, connects through there. But then it keeps going, and then, oh look, it does something with this inductor, and then it's coming. Stop it, I don't want to edit text. So it comes through down here, comes up here somewhere, and then it connects to there. Are you kidding me? What in the... I see you're working on something. Do you want to do an update? Yeah. Yeah. I don't know if you can tell. Am I... Oh, I'm covering it. Let me show you something. So down here, Windows, right before the stream, Windows decided it wants to do an update. So it was totally aware that I needed to use it. And so it's like, yeah, now's a good time to do an update, right? Someone was trolling us. It took 30 years, but they got us. They got us. Let me tell you, I can see it. Sure. Hi, Jane. How you doing? Okay. What a rat hole. I was like, let's do this. Okay. So all of that because this signal over here, oh, I need to minimize that. Actually, I should just shut that off because we're not going to use that anymore today. Okay, so that was game.ground, which I suspect was just a ground at some point. Well, I guess it's a ground through a inductor, so I don't know. So we're going to go game.ground. I'm glad I did highlight it though, because later on we're going to have to deal with that. So it's good that it's identified, whatever it is. Okay, so there we go. So we got those labeled out. Now we need to finish these connections. So, 5. So R79 is going to connect to 5, which connects to PDL0. Okay. So we're going to take and just C to copy that, rotate that over. Well, that's weird. Huh. Had a little graphic artifact there. Little glitch. Little glitch, huh? So this is going to be pin 8, PDL1. And then over here, we'll do that. And then over here is pin 4, and that's PDL2. And pin 3 is over here. All right. Cool. So then we can probably grab all of this stuff and just kind of move it over to here and get this back into our page. Clean look. Hey Matthew, I'm glad you're looking at the I'm glad you're watching the MOSFET video. Yeah, that was that's clearly the most popular one I've ever made. Fun fact, I was actually contacted by a recruiter who wanted to hire a product manager for a MOSFET company. It was basically managing the product line, managing a MOSFET product line. And it was while I worked at the capacitor company, and so, I was said I would talk to the guy. I wasn't interested in going anywhere, but sure, I'll talk to you. And he said, well, I'm a little bit concerned because you're a capacitor person and they really want a MOSFET expert. And at first I'm like, well, if that's the case, then why are you calling me? I mean, did you just call to say that I'm not a good fit for the job? And so I said, okay, tell you what, go to YouTube, type in the word MOSFET, and tell me whose face shows up. And he irritated the heck out of me because he said, oh, so you paid a lot of money for ads to get to that spot. And I was like, no, I just made a really good video that people like and resonate with, which is what you probably want in the person you're looking for in this job. And he said, oh, well, I don't see it that way. I was like, okay, well, you're not the hiring manager. You're just the recruiter. But at that point, I was like, I think I'm done with this guy. And in fact, I did actually meet the person who ended up getting the job, and I'm kind of glad I didn't. So, anywho, welcome to the stream, Matthew. I want to make a channel where I go by Mr. MOSFET, except that it'll be about tacos. Okay. Paul Daniels on YouTube has similar software for a different DMM module. Okay, that's pretty cool. I can look and see what he was doing. Tizboyo actually gave me the idea because I think he got it from Louis Rossmann, who I have a very hard time watching. But it was something that I had wanted. I had actually tried to do it with my old multimeter, but anytime it went into remote, it would turn off the screen, so it sort of made it useless. And then I forgot about it, and then Tizboyo said to me one time, he's like, yeah, Louis Rossmann has a DMM show up on screen. And I'm like, I really want to do that, but mine doesn't support it. And then when I found this Bluetooth multimeter, I was like, oh, I bet we can make that work. And then we did. I say we, even though Tizboyo and Geekboy did the hard work. And actually, I mean, for recorded videos, I thought I would use it, and now I'm starting to realize I'm not going to. But for live streams, I definitely wanted to have it. No question asked. Okay, so... Okay, so I think this section's done. That section is done. What I'm struggling with is I'm getting lost. I don't know where this whole blob of mess is. I guess that's what this is over here. Okay. So how am I going to highlight all of this and move? I guess I can do that. What am I moving? So that connects to 6 and 8. So let's move this over to here, and that connects to this. So BA bus 01, MD bus 01, 2, 3, 4, 5, 6, 7, U15-32. We need to label this other side over here. These look labeled. This is missing a signal, so we need to figure that one out. Those two, that's connected. So then we got to go and do all of these. Oh man. Okay, so I think we're going to start by labeling these over here. And then WTF. What is going on right here? Is this something wrong with the PDF? So it looks like I think I drew this with the proper gate. But I'm thinking this is a problem with the PDF. Dr. J sent me another schematic, and I might have to go look at that one and double check what's going on with this. So we'll do that. So test point 73. There's a couple test points here, and then there's a NOR gate, a flip-flop, another flip-flop. Let's see, this is a... is that a NAND? That's not a NAND. What is it when you have negative inputs But the output is AND? I guess that's an AND. Okay, so we got a lot that's going on over here that we're not showing. So let's do the easy thing first. Let's finish filling out the chip, and then I'm going to come back to these other things. Can you explain what you're doing? I'm kind of confused. So I'm using the program called KiCad to redraw the schematic for an Apple IIgs. And this is actually part of a project which I called Bit Preserve. And so what Bit Preserve is, we're redrawing schematics for vintage computers and probably eventually video game systems into KiCad. So KiCad is a schematic and PCB program. And so right now I'm on the page that is the disk controller for the Apple IIgs. Eventually I will be using this to create a portable Apple II, which is what my original project was like a year and a half ago. But then I needed a bunch of circuits from the Apple II and realized I had to redraw a bunch of things. So then I was like, okay, then let's just make a project out of redrawing them. So that's what we're doing. In terms of the circuit board, I don't care about the circuit board. We're not going to do the circuit board. We're just trying to archive the actual schematics. Yeah, so that's what's going on there. I don't know why. This is, oh, I know. Oh, I know what's going on. Let me do this. Usually you guys would be able to see this, but why? Oh, that's why. Interesting. Interesting. I did not realize this, but the explanation won't go over because it's too big. Huh. Well, YouTube, you are being kind of a pain, aren't you? Interesting. Okay. Well, there's something going on with YouTube chat tonight. I can't get it to work correctly. Let's see, not A and not B equals A or B. Okay, so then it, because if it's and you invert it, so 0 0 would actually be 1 1, so that would be correct, and then 0 1 would be 1 0, that'd be incorrect. 1 1 would be 0 0, that'd be incorrect, and then 1 0 would be 0 1, and so that'd be incorrect. So now a NAND is, if you put in 0 0, you would normally get 0, so you get a 1. So it's like it's an exclusive and, or it's an exclusive not and. So the only time it goes high is when both inputs are 0. Huh. Okay. Anyway, one thing I don't need to worry about is I don't need to try to re-engineer whatever they did originally, because the engineers that came up with this design are a hell of a lot smarter than I am. So I'm not going to worry too much. Okay, so first let's label this crystal. That's just bugging me. So let's make that Y2, and its frequency is, oh, that's good. I can't read it at all. 3.6864 megacycles. Okay, let's move that over here. Come out and come out there. Okay. Now, this side of the schematic is going to be really descriptive things like this is going to be 22. I bet this next one is, oh, I can't see the next one. So down here we're going to go to 15, and then down here is going to be 16, and this one is 20, and then this one is 19. Oh goodness. UE 15 dash, and that's going to be 19. And let's go down here, and this one's going to be 25. And then this will be 24. This one's going to be 29. This is 26. And this is 27. All right. So 25, 24, 29, 26, 27. These are easy to check because this is, whoa. Oh no. Why does this say UE15 when this is UF13? Oh, son of a... Middle mouse button does not scroll. So this is UE1522. Are these connecting to UE15? No. What? Oh, that makes me nervous. Why are these? Because I feel like these should be... Normally the convention that this schematic follows is that... Oh, see, this one's different too. Woz loved to reduce chip count. Oh god, did he? Yeah. Okay, we're just gonna keep doing what the schematic shows. I'm confused by it, but I'm not gonna try to solve it. The labels aren't following the convention I expected, and I'm thinking there's been a couple times where that's happened, so I really don't think I fully understand this labeling convention that they've got going on. But that's okay. Okay, so now pin 14 doesn't have a label. Okay, the rest of these don't, but this connects to this one. So let's undo that. W for wire, connect to here. And let's see, 31 connects up somewhere, so we gotta go find that one. All right, so let's save this for now. And then let's go find, oh, this one's not connected because it's too far over. Nope, just didn't draw it far enough. Okay, so let's go find where 31 gets connected. So it's 1, 2, so it's 1, 2, 3 over from, right? 1, 2, 3. Okay, so as long as you follow this bundle, it's the third wire from the right. So it breaks here, so it goes 1, 2, 3. So it's going to this pin, pin 3. Oh, that's convenient. And then that comes up to nothing else except for MSY1. So let's just see. So I'm going to name this one MSEY1. And let's go all the way down. So we'll add a label to it over here, and I'll probably put the global label right there. And then just carefully follow this one. Okay, so that went to 31. So that's what's going on with that one. So that's a really good example of why I dislike schematics that are just drawn with lines instead of net labels. Now, as a printed schematic, I understand why they did this, and that's fine. I'm not saying that this is bad. I'm just saying that that's why I don't like that, is because it's really hard to see where things go over a very long distance. So it looks like 21 connects to 15, so that makes that easy. So let's just go 1 over and then down. And then 22, and then I think all we got left up here is 14, which is easy. It's on the outer edge of this bundle. And it goes up to MSEX1. Awesome. That's what we need. That's what we needed, is a name that everybody can be totally mature about. 2GS has an operating system more like a Mac. The Apple II just runs BASIC and a monitor program in ROM. Yep. Yeah. So the Oh, I see. The question is, what's the difference between Apple II and 2GS? So the GS actually stands for graphics and sound. So the 2GS has an improved graphics chip, and it had an improved sound chip. And in fact, the person that worked on the sound chip for the Apple II, I think later went on to work on a chip for the Amiga. And so the 2GS was actually a 16-bit computer versus the 8-bit of the Apple II, but it used the same, but it used a processor that was backwards compatible. So it was basically the 16-bit version of the 6502. And so in the 2GS, there's a special chip called the Mega 2, which is actually what emulates an Apple II. And that's the one I'm after, is I want that chip to build a portable Apple II because it reduces the number of chips that we need to make a portable computer. But so the 2GS was able to run almost the entire library of Apple II software, as well as its own. And so it had a 16-bit version of ProDOS, and then later it had a operating system called GSOS, which looked very much like the Macintosh OS, except with one significant difference. It was in color. And so it was, for all intents and purposes, the 2GS was just as powerful as the early Macintoshes, except it had more colors and it had more RAM. And so it was actually much more usable. Also, the 2GS could run Apple II software, whereas the first Macintoshes could not. So it's a shame that Apple did not try to promote or extend the life of the 2GS at all, because it is a really great 16-bit computer. Almost everyone that bought a 2GS just ran Apple II software. And so there's very little software that makes use of the enhanced graphics and chip and graphics and sound. And it's really sad because it is a fantastic computer. As you can tell, I'm a big fan of the 2GS. Okay, so I think we got that chip done, which is cool. So let's go do this logic mess that's over here. I don't know why these discrete logic circuits always just like make me want to like run away. So 70, 71, there'll be 69 down here. And then let's see, UF9B. So is this UF9A? Oh, I see. So this is A, that's C. I don't see the other. Don't see the other gates. Wait. Oh my gosh. Why did they draw it this way? So this is UE7. This is A. I don't know where B is. Here's C and here's D. So this symbol is drawn as a negative input AND gate, which is the same as a NOR gate. Yep, Apple did not bring it back until the LC with the PDS card, which contains a version of the Mega 2 called the Gemini. And in fact, the 8-bit guy did a pretty good video on the Gemini chip. I want to say he did that in the last 6 months or so, because as soon as I saw it show up on Patreon, I was like, oh no, because I was going to do a video about the Mega 2, and now that he's done that, there's really no reason for me to. And he probably did a better job than I would have. So, okay. So what we need to get ourselves is a 74 LS02. And why is that happening? Okay. And we're going to grab this one, and it's going to go somewhere over here, and then we're going to put this over here and put this over here, but this is going to be unit D. Ooh, alternate symbol. Oh, look at that. we can even follow the same. Oh, look at that. So cool. All right, so let's use X to flip that. So that's, nope, 2 and 3, 1. That's the A unit. That's going to be E7. And then this one's going to be E7. And this is going to be E7. Okay, so this is going to connect to up here, which I'm just going to go like this. I'll delete this line. Okay, and then B, nope, I'm sorry, 8 connects up to pin 1 up here, so we can make that happen. So let's move this like to here, and then wire this down to here. Nudge that over, grab this line, come on. Let's, oh, what are you doing? Let's do that. How soon are you closing the live stream? Less than an hour. Yeah, Woz was really adamant that they should have pushed the 2GS instead of the Mac. To some extent, I agree with him. I think they should have. I think they should have tried to ride the 2GS for a little bit, because if you go back and look at the Mac, the Mac 128 was a terrible computer. I mean, technology-wise, they did a fantastic job, but as a product, it was terrible. With 128K RAM, it couldn't even copy a disk without multiple disk swaps. And so it wasn't very usable because it didn't have enough RAM and it was slow. So it wasn't really until maybe the Mac Plus before that machine really became a good computer. And they could have probably rode the 2GS for a couple of years and given time for the Mac to sort of evolve into something. But who knows? Let's see. I never heard about the 2GS. Yeah, I remember they were when I was in elementary school. We got, that's when, I think it was around the time when they were released, because we got a couple of brand new 2GSs, and it had a mouse, and I was like, I thought it was so cool that it had a mouse. And so I used to plan my recesses, because we could use one recess. It was something like 1 or 2 recesses each week we could do in the library. And so, or maybe it's because we had 2 recess periods each day, and we could spend one of them in the library. And so I used to go outside on the short one, and then on the long one, I would go to the library to play with the Apple IIgs. That was always really fun. Okay. Man, I really miss having my chat in one window. It was always so easy. Wasn't the original Mac a good computer though? I mean, when I say original Mac, I'm talking the 128K Mac. I mean, it was, I think it was a good, that's why I feel bad saying it was a bad computer. It just wasn't very usable because there just wasn't enough RAM to do anything. And so once you got like the 512 version of the computer was much more usable. And then I think really around the Mac Plus time, that's really, once it had a megabyte of RAM, that's when those computers really became really good. That said, I just want to point out, I do have a Mac 128K, and I also have a Mac SE. And in terms of the all-in-one Macs, the Mac SE is my absolute favorite. That might have been the first ones that came with hard drives. I'm not sure if previous models did, but in my life, I've been lucky enough to have 2 of those now. I only have 1 today. And the SE with a hard drive is a great little Mac. In fact, my senior year of high school, I wrote most of my papers on a Mac on one of those, and then I almost took it to college with me, but I think the power supply blew on it. But I actually used it for almost a year. I got one free from my high school. We were throwing them away, and I was like, "Can I take it home?" And my I was gonna say my teacher. It wasn't. They weren't my teacher, but the teacher I was working with, she said, I don't know what the rules are on taking these home, so why don't you just make sure that you take it when nobody's around? It's like, okay, understood. All right, so we got to get 13 out of here somehow. But first, let's get this, because 13 is going to be a pain. I got to go look up the symbol names. So this one is from here to here. Then over here, this is, let's do this one. Let's go 117. Legal reference, oh, TP 117. All right, 3 goes to ground. There's gotta be a ground symbol we can use from someone. And then 2 is gonna connect to the same thing as 13 does. So let's just take this, do that, and then we're gonna get a global label. And that's gonna be, that's this mess right here. But I'm pretty sure that's A2 rw.h, and what we're going to do is, this is connected to pages 1, 2, 3, so I think if we go look at page 1, there should be this signal somewhere in here. No. Okay. Then I don't understand. Now I'm actually wondering if page 1 is done, because there's a bunch of empty pens over here. Okay. Let's go look at page 2 with the Mega 2 chip. This is the one that I care about. So I recognize a lot of these signals. It's this one. So A2R-WH. That's what that one was supposed to be. So let's leave that sheet, go back to IWM, edit this one, and paste that. Okay. And then that's another mystery. I think that looks like RW. Shoot. So is that read write? Do we see something on here that looks like read write.h? I don't see it. It's not going to be the RGBs. Huh. Anything over here? No. Oh. Okay. Okay. So that connects there, it connects there. That's troubling, because I'm struggling with what that one was supposed to be. I was guessing like a read write. So let's try page 6. Capacitor page. Oh, there's no way it's going to be on here. I don't know why the page, those must not be page numbers. Shoot. Okay. I'm not sure what I'm gonna do. Because I can't read what the signal is. Yeah, I enjoyed using System 5 through 7 after that. It stopped being fun. Yeah, System 7 was probably I think 7 and maybe 9 were probably the best operating systems for the Mac, the classic Mac. Do an Apple TV schematic. Yeah, I don't really think so. I mean, I'm pretty sure that schematic doesn't exist on the internet, so it's gonna be pretty hard to do that. Yeah. I just remember because when I was in college, I was one of the few because I worked for the computing center, and I was a lab monitor or lab assistant, or I forgot what they called us, but I would go into the labs and help people use the computer labs and maintain them and stuff. And I was one of the few that could do the Mac stuff. And we had System 8 on most of our Macs at that time, and it was so unstable. And then by the time I left, we were mostly upgraded to 9, but then right about the time I graduated is when OS X came out. And so I sort of remember there was that crossover period of compatibility mode and stuff. But I didn't get back into a Mac until a couple of years later, when OS X was finally like it was like firmly implanted and doing really well. Okay, so I'm still kind of bothered. I don't know what. Oh, I know what this. Oh. Sorry to be so loud. I know what it is. It's ready. RDY. Yep. So this messy signal over here on the right is actually rdy.h. That's what that is. Whew. See, just babble long enough and I knew I'd figure it out eventually. Okay, so now what is it connected to? Okay. I'm not even ready to do anything with it. I just have to try to remember that's what it was. Okay. So irq.l, not ready for that. So this is UE7-D, pin 11 is going to go to something, but then pin 12 goes to whatever this is. So let's add this and go C038-F.L and do one of these. And then there's a test point in there. Are you kidding me? Let's do that. Hit M to move this back. Wire. Copy the test point to the C. That's going to be 118. Let's rotate that, go upside down so it doesn't interfere with that one. So over just a little bit. Like over here. So 11 is going to be BA bus 2. So we'll do like this. Then it's connected to something else. So I wonder what that is. Let's go take a look at that. Is this just connecting into the bus? I bet that's what it is. Because it's this top one, now it's the right one. Then yep, yeah, it's just the bus connection. Cool. We don't need to worry about that. Okay. And then 13 connects to TP11. Wait, that's not right. I'm looking at the wrong thing. Down here. So this connects into pin 9. So let's see. We need to try to move all of these ever so carefully down. Zoom in on here. And then we're going to take this and move that to about here and do a wire connection to there. And then we'll add another test point. And this test point is going to be field reference 72. That over field reference. Yes. Right. So D output 13 goes to 72, goes to 9 of the other input. And then that connects 8 and 9 are connected together, and those go into 1. Okay. And then we can add a label for this one, which is UF9-8. Don't really super like that, but that's what we're going to go with. Okay. And then 69 is connected to from up here because this and that are the same node. And then cref.h, I see that one kind of hanging out over here on pin 23. Let's see, does that connect to something? Nope, just goes to the global label. So what I'm going to do is I'm going to add cref.h. I'm going to do something like this. Then we're just going to delete this line. Delete that line, wire, and wire. Don't need that. Okay, save that. Used to do a video on soldering surface mounts. I sort of did. I did a video on the Pyramid Arduino when I soldered that one. So, and then we'll be doing a stream on sometime next week. We'll be soldering. We'll do a reflow solder of the sensor board we designed a couple weeks ago, and then I also did a bunch of Element 14 videos on soldering. So got that covered. RDH1 is connected to VD12. Oh yeah. I just haven't. I thought I was ready to make that connection, but I haven't even drawn the flip-flop yet. It was just that the squiggly mess over here caught my attention, so I was trying to figure out what that was before I needed it. So the .h I don't think means horizontal sync. From what I've been able to tell is the signals are labeled with their assertion level. So .h means it's active high and .l means it's active low. RDY I think is actually a signal from the it's a signal that I've noticed on all of the CPU stuff. I don't know that I saw it in the video schematic, and so I think it's like a bus ready signal. I haven't looked into what it actually is, but based on where I've seen it, I think it's something to do with like is the data bus ready to do something or not. And I feel like it should be on this schematic, so that bothers me it's not. We'll have to look into that later. But okay, so got this one, that's here. So cref.h, yeah, I just did that one like 2 seconds ago. C038, IRQL, where's the IRQ signal? It's going to the init. That's the one that I was missing earlier. So let's do, so what would be ideal is if I could do IRQ.L, and then, yeah, see, that's gonna fall right on top of that. So what I really want to do is like put it like out here, or we can do this. This is what I'm gonna, this isn't super clean, but, oh. I'm gonna do that. Copy. Use a second mouse button to scroll back over here, do a paste. While it's hovering, hit X to flip it, or Y to flip it, and then do that. And then I'll use G to grab the label and move it out here just so it lines up with everything else. So that takes care of that one. And then we're up to the ready. So the other way I wanted to double check this is if we look at this gate array. So that one's connected to these two, 13's over there, 12 connects up to 4, and then it goes out to something else. And I think that something else is that flip-flop. Okay. And then all these other signals are connected to something that goes up. 6 and 8 are taken care of. Okay. So what I want to do now is we've got unit A is done. So now we need to add the flip-flop. So let's see if this standard flip-flop is going to work for us, or are we going to have to get creative? Because I think this is a 2 unit. So this is UD12 LS74. Pins 1, 2, 3, 4, 5, 6. No 7, 8, 9, 10, 11, 12. So yeah, it's a dual package. So we need a 74 LS74. Alright. Oh, maybe it's a quad package after all. Okay, so that's going to somehow... Where's that going to go? It needs to connect to, like, what? Pin 4 of something over here. So maybe we put that here. And then we can move this up here and out of the way. And then we'll copy that, move this over here. We're going to have another one of these, I guess. And then this one, we need to change its unit to, let's try B. So we get 12, 11, 13, 8, 9, and 10. Okay, so see how this is going to work out. You ever consider writing a children's passive components book? I don't even know what that would look like. Adafruit does have a coloring book for electronics, which is kind of cool. They publish like each letter of the alphabet. They publish something related to electronics, and then it's a cool little project that kids can color. I don't know if they've ever actually printed it, but I'm pretty sure you can at least download it. Okay, so first thing this is going to connect to, we're going to come over here, do one of these, copy this, and this is going to be rdy.h. Now kind of do this, try to line those up, and then the clock will connect to something up here, which is actually connected to that clock. Okay, and then the data is connected to ready. All right. I really don't like when things crisscross like that, but here we are. Go over here, hit a G, come over here. Okay. Then 11 comes up to there. So that's going to go to 7m.h. So my inclination is to just do 7m.h and then move this up to here. Nope, that's not going to work. So what we're going to do instead is same thing. One of these. .m.h and then this. All right. And then that's going to connect to the same thing as that one. So let's get that. And then I'm going to do one of these. And then I want to add a test point. And that's going to be test point 3. Okay. So we got that connection covered. So 9 comes out of here and it goes into 4. And then 4 gets a test point, right? It gets test point 1116. So let's copy that, edit 116, and then move that over to the other side. And then, we could do this because it's not terrible. Not my super preferred method, but we can do that. And then let's go ahead and label that node to be UD14-4 for whatever reason. They labeled it, so I will too. And then we can label this one. And that's going to be UF9-1. All right, let's label the name. Let's name these. Should be UD12. That should be B. And this will be should be UD12, right? Yeah, duh, just did that. There's at least 2 different boards for the 2GS. Yeah. There was, because there was like, yeah, I know there's at least two. This one is based on the ROM 3. So my question would be: are there two boards for the ROM 3 version of the 2GS, or is it that there's the ROM 01 schematic and then the ROM 3 schematic? That's the only thing that's kind of, I haven't dug enough into to know for sure if we're going to run into that later on. But I mean, with almost all of these vintage computers, just like almost any electronic design, eventually there is going to be more than one version of a board, and so the schematic gets revved, the PCB gets revved. You know, it's hard to have them both. Now, the nice thing about trying to organize the project the way we're doing it in GitHub, we should be able to track different versions pretty well. Like Commodore, super notorious. There's a couple dozen, or there's at least a dozen variations of the Commodore 64 schematic. And then I think well, actually the schematic, there's not that many variations. There's probably 5 or 6. And then the PCB has a dozen or so variations. And so then it's like, well, how do we monitor that? Because the schematics we have don't describe all the variations on the PCBs. And so that's been a challenge for the guys working on the Commodore stuff. But they've done a great job so far, so I'm not too worried about them figuring out the best way to do it. Let's do that. Okay, 5 volt, 5 volt. No connect. 6 needs to go somewhere. Okay, we'll do that next. Data is reset. 3 is the 7m.h. To test point 3, which we covered down here. Then down here, this goes to 9. UD14.4 goes to pin 4. But it also goes to pin 12, which it does. And then no connect. Clock 7m.h. 2 goes to ready.h. 13. Okay, that looks good. So now let's get this output. Should go to, I'm just going to do this. dres.h. Wire that. And then that connects to, oh, that goes to 73. Okay. So what in the world did I do then? Okay, so 117 does not need to be anywhere near that high. So let's use G and get this down here, and then I can just derez this over to here, and that goes to 73. Beautiful. Oh, beautiful. Okay, so well past 9:30 at this point. All right. Let's see. So all I want to focus on at the second is, let's see if we just make sure we got this section that's been kind of a mess. I want to make sure this is captured correctly. So first, let's look at the chip and just make sure we got all of it covered, because that's usually the easy thing to see. So MSEX1, MSEI1, and then 30 connects to this one, 21 connects to that one, and then it's basically these pin number UE15 plus the pin numbers. Okay, those we covered. Over here, UE1532, that looks right. MD bus 7 6543210, and then BA bus 1, BA bus 2, and then 12 connects to 32, which also connects to the side of a crystal, which then connects up here, 15, 13. P clock goes to cref.h. Let's make sure that's where that went. It did, cref.h. Chip enable goes to 1538. Read goes to 1541. And 1540 goes to, looks like test point 70. Uh-oh. Wait. So 40 is, oh, I'm sorry, 41. Let's do that one. 41 goes to test point 71. 40 goes to test point 70, which is also the output of this this array. And then 6 is IRQ.L, which I'm pretty certain 8 and 9 go high. So what I want to double check then is where do all those others go? Okay, so chip enable is 69, which is also connected down here. And since we've already got all these other wires, why not? Why don't we just do that? There we go. So that way it's clear that those are connected. So that's pretty good. Okay, so then we move over here a little bit. And the array we just did, it goes to 60, and it should go to, so 8 goes to 71. Don't know why that gate's missing from this schematic, but that's got to be a type problem. And then 2, 3, 9, 10, and 11 are connected together. So 2, 3, 9, 10, 11 are all connected together. They go to 73, they go to DRes, go to flip-flop. All right, and then, so 12 goes to UD14.4 and test point 116 and pin 4. Okay, UF91 goes to 5, 117, and there. Okay, move this over a little bit. This over a little bit. So down here, 8 and 9 are connected together to 72. They output to 69, and they also connect to 1. And then 13, okay, VA bus 2 is 11, and then this goes off to the bus, so that's covered. 12 goes to C038F, and then 118. Wow. All right, I think we got it. This is A2-W right high, and it goes to 2, 3 goes to ground, 1 goes to that mess. Over here, this is ready.h. Up there, there. Okay. Okay, got that section done. Holy cow. All right. So I think, okay, I did want to see this, what is going on here? So HD select, that connects to global label, and then 153, and then 470, and that's R190, and then that's supposed to connect to J18-16. Okay, so let's just grab all of these, move them over here, get a label, and what did I say? J18-16, J8-16. So we're just going to do that. All right. Ah, come on. There we go. So I don't know why that was missed before. Let's come over here. So we have, this is labeled. Okay, even better. It's already labeled. Awesome. All right. 1, 2, 3. This is the wrong ground. So let's get a ground ref. And make that invisible. Okay. Negative 12, 5, 12, 9, 11, 12, 13, 14, 15, 16, our data. Oh, ho, 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 ho. All right, sense looks good. That looks good. Our data. Oh, interesting. So, wait. So on here, I have 22. Did I label it? Okay, the other thing. Okay, that's name. 22 comes down here, comes down to here, goes there. It's the cross of those mess. Okay, that goes to our data there, so that is correct. Okay, that's looking good. Hey, Tripetti, thanks for the follow. Welcome to the stream. We're just doing the Apple IIgs schematic. We're working on a page that contains the IWM, the Integrated WAS Machine, which was the disk drive controller that was used all the way through the Apple IIgs, which is crazy to think about. I mean, it received updates and like this actual IC and stuff, but still blows me away just how long this chip survived. So, okay. So my cursory glance says this half of the schematic, this half of this page is done. So we got this whole section is done. We did this section today. Over here, we did this section today, and then we cleaned up the rest of this. So I think where we're at is these chips over here. That is what it looks like. So let's kind of try to get a good look at what's left. Yeah, so it looks like we did a little bit of this one, maybe? No, that doesn't look like that. Actually, not sure what this is. 1Y, 3, it is. It is part of this. Okay. But I don't think these are labeled correctly. Oop, 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 oop. Huh. Interesting. This should be an AM26L3S. That's a mouthful. I wonder if I found an equivalent. I think I found an equivalent part. That's why these don't match up. Let me check something. Oh, okay. So then okay. I know what it is. Haha. Okay, let's edit in Library Editor. I know exactly what I did. No, I didn't. Okay. I thought the name was going to be wrong. It is not. I wonder why these are labeled this way. Or maybe something happened because this is labeled wrong too. This should be a 26 LS30. This is the 32. Huh. I wonder. I must have copied and pasted something messed up. Okay. Okay. Well, I don't think I'm going to tackle this tonight. I think this is going to be my stopping point because I'm starting to run out of steam. But we'll be able to, because it looks like we got a couple things we got to clean up here. Although, I mean, this isn't in too bad shape. And I think in terms of a starting point for when we pick this up, this will be a good place. Because I think that'll be a good place. It won't take too long. That's probably, I don't know, I'd say about an hour's worth of work right there. Maybe a little bit less, because I don't think we have to create any new symbols, which is up until now had been slow, which always slows me down. So yeah, like, why is this in here? That shouldn't be there. I must have added that and then never used it. So, and then this looks like this is supposed to be, I don't think this is labeled correctly. It is not. It is clearly not. Yeah. This is game ground. That's the one we found earlier tonight. And then this is L10, and it is 10 oof Henrys. So let's just clean that up right now. I can't edit it. Weird. Okay, so we got that done. Yeah, I feel much better now. Which means, wait a minute. Oh, I see what I did. Okay, I see what I did. I'm gonna fix this. I got carried away when I named these before. So let's move all of these. Okay. Then this one, 1, 2, 3, 4. Yep. Game ground. We're gonna leave that one. That's long enough. And then this is another connector, which maybe we don't need, because I see 15 and 16. So I don't think we actually even need this. As I said, I'm not going to finish this tonight, and then I think I'm about to finish this section. Okay. Okay. And then 15 goes to 631. Okay. Except this one, yeah, it does go up to there. So because that's H5A, H5B. And then wait. Something's wrong. Oh, we're missing some stuff. That's why. We need another resistor pack in here. Okay. Okay. Oh, that's not as simple as I thought it was gonna be. This is gonna be a good part to pick up because for some reason I didn't include another set of these, and I'm wondering if it's because, let's see. Yeah, I think I just need to create another set of those, and I didn't. But that'll be a good place to pick up, and then we can clean up these, and then this page will be done. So that'd be cool. So, man, you're so close. It's like this is mostly done. Which was the other one that needs more work? Sound needs a little bit more work. And I think that's it. And then I want to double check this one because I feel like there's a couple signals missing. Let's just take a look real quick. Are these pins open on the original schematic? They are. Wow. Ah, but look, see, I did miss. Oh, there it is. Ready, reset. Does this schematic, do I see A2R -W? I do. Did I see it over here? A2R, okay. I guess I missed it the first time. Okay, cool. Yeah, so that's actually looking really good. I mean, that's really exciting because I think we're basically down to this section plus the sound, and then we'll have to go through each page and just give it a really good look just to see is there any like other places where we said, oh, we'll do that later, and then we never bothered to do it. I do know there's some pages where I need to add global labels. Those are missing, but I don't think that's going to be a huge deal, even if we don't add them. But yeah, cool. All right, so let's, do I want to save changes? Yeah, because I added that highlight. And then let's close this guy. So that closes all that. And then let's go, worked on IWM page. Almost done with it. Thanks, stream. So let's commit that. Push that. Turn this off. All right. So exciting. So exciting. All right, chat. Well, I want to thank everybody for coming by and helping out tonight. We are going to do another stream on Friday night. I'm not 100% sure what we're going to do yet, but my goal is to do something in the laboratory. So we'll be back. Well, for me, it's downstairs. For you, doesn't really matter. You just come to the same place you already are, and then you'll be able to see it. But yeah, we'll do something in the lab. I had gotten a couple of new things in the mail. I'd like to do something like video game related, so maybe we'll solder some capacitors or something. There's also a board I need to build for an Element 14 video, and if I find all the parts, we may actually do that. And then Sunday is, like I said, Sunday we're going to take a look at this cool board from NXP, which it has a camera on it. There's a camera on the top. USB-C shows up as a camera on the PC. And then what I was playing with it on last night is it recognizes a face, and then you click a button and it'll recognize, and then it'll remember that face. And so that's kind of cool. We'll see what we can do with that. But yeah, we'll check that out, see what it can do. And then yeah, so that'll be the Sunday morning. So yeah, so Friday night we'll do something in the lab. Sunday morning we'll be playing with that. We may actually play with it in the lab because I've got to shoot some video, and I'll probably just leave my computer in there. So cool. Thank you to everybody that helped out. Always good to see you guys. You guys really do help me with actually making this fun to do, if that makes sense. If I didn't have the stream to finish this project, I don't know that I would have ever finished it. because it's already too easy for me to be like, I don't want to work on it tonight. We're not going to do it. And instead, we're almost done with the schematic, which is freaking awesome. So I'm going to send us over to Amateur Radio. Hopefully he's still streaming. Last time I tried, he stopped streaming as I did the raid. But he does, well, as you might imagine by the name, let me make sure he's doing something, is he does amateur radio stuff. So right up our alley, really cool stuff, nice guy. Oh God, I gotta watch an ad. So I'm just gonna send you guys there, see what happens. All right. Okay, thanks everyone. And remember, if you wanna keep the conversation going, head over to AddOhms.com/Discord, where you can join our Discord server and chat and stuff. All right, thanks a lot, guys.